Okay, welcome to the weekly wasmCloud community call, June 11th. Today we got quite a few things on our agenda. Let me just share my screen. This will be posted later today, but I know GitHub's having a couple of issues. Looks like now it's just API authentication issues. So today we're going to be going through, I'm going to be showing off auto-scaling workloads. This closes out one of the open issues out there. Adding some additional Helm enhancements, really just for additional knobs for, especially if you want to further critique how Wasm Cloud's installed, including if you're using your own custom host. And then Bailey's going to be showing off a thing she's been working on with workloads with multiple subscriptions and handlers. And we'll also be doing their documentation of the week as well. So to start off with the first one with auto-scaling workloads. This was opened up and inside our project roadmap for this current quarter right now. And I was trying to get this across the line. It's really, really close. And I have a demo just showing off exactly how this all works. But basically what this does is for the workload deployment CRD that we use inside Kubernetes to schedule a workload to a host, this adds now the scale subresource, which that allows for basically horizontal pod auto scaling to inside Kubernetes to work with our workload deployment. This works based on using that subresource, and it sets up the replica path and the label selector path. Now, HPA literally stands for horizontal pod auto scaling. Since we're not really scheduling per pod for a workload component, because that would just completely defeat the whole purpose of, or at least part of the purpose of getting high density. We have each host still just a single pod, so we don't want to really to scale the actual host
Yeah.
pods. We want to scale
Okay.
up the actual workload deployments.
Colin, I don't think you're on mute there, bud. There you go.
I just muted him. Yeah. Um, yeah. So, anyways, this PR is what adds to that, and just to show off exactly how this all works. What I did is I do have a test a demo script that I'm going to be uploading into our public Cosmonic Labs section, so you can use this against Wasm Cloud as well. But the first thing you do is you can set up your kind cluster. Just follow the documentation that's up on Wasm Cloud Docs. And then you can install Prometheus and KEDA, which is Kubernetes event-driven autoscaling. That is also a CNCF addition to Kubernetes. And that also allows for you to take KEDA to point to Prometheus and take an external metric for controlling the horizontal pod autoscaling CRD. Now, what this demo does, I did not want to add any more complexity to the demo. Typically, what you would do for in this case is you would have this actually talking to your ingress to measure like a back pressure to see if if responses are taking too long. What I actually did instead is inside the workload, I'm just deploying the typical hello Wasm Cloud workload component. And I just made it so the target metric is actually a fuel metric coming across and just saying, I want to always keep 10 requests per instance out there. So my local script makes about 450 requests a second. So what I expect is at first you're going to see just one instance handling all 450 requests. But then over time, it's going to keep on scaling down to, or scaling up to roughly 446 workload deployments and 10 requests per second. So it should still equal 460 coming in. So going back to the setup here, so I do have Prometheus and KEDA installed, just by the Helm charts. I also configured OTel to have it Spire as well, just for a quick dashboard to show that how it is routing inside the workload components. And then as far as deploying Wasm Cloud, I followed the same steps, but I did override some values here inside the host group section. And this was really just adding meters enabled. So that's going to allow for each HTTP invocation to be reported back to the OTel collector endpoint. And then it's going to report that every 5 seconds. So there's going to be a little bit of delay that's coming around. As far as the KEDA side of things, on the KEDA CRD, I said go ahead and just make it so you can have up to 1,000 workload components that are deployed. The minimum should be one. It is the Hello World workload deployment. And then just to add some stabilization, so it's just not constantly updating that workload deployment over and over and over again. Just go ahead and update it every 10 seconds just to give time for the whole reconciliation process to come around. So I already got all this stuff configured, and I got a load script here that I'm going to run. And this is just going to start just calling out to local hosts and just constantly pinging to that kubectl, I'm sorry, to that kind cluster that's locally. And since the kind cluster followed the wasmCloud deployment steps, that's just simply port 80 going straight to the manifest. So if I look at my workload deployment here that I have running, so this is the Hello World application. And if you notice, this is taking any ingress coming in from the Kubernetes service called Hello World. So now if I look at that, this has all the endpoint slices that are registered to all three hosts because it's already spun up to at least 3 instances that are spread across all the hosts. And this is where it ties node port 3950 to the target port 80 on the host. 3950 on the WasmCloud standard kind default install already has a local port forward to it. So that's why I can just say curl localhost and it routes all automatically. So now if I look at my host here, these are all the 3 hosts that I have running right now. And I can actually go inside each one and I can see this one already has 12 of the instances and there's no other Wasm components running other than this test. This one right here has 10. So I got 22 and got 7. So that's 29. So if I look at my watch here, it has now a total of 38. And if I was to take these 2 numbers here, I'm going to get close to 460 transactions a second. As long as this is right around 10, it's not going to try to scale up anymore. I'm hoping that we might see just change a little bit there. But while that's still going, I'm just going to bring up the Aspire metrics here. And just show how this is all routing here. Now, I did restart my host a few times, and so this is why I probably should have cleared this out before the demo, but 3 of these are going to have actual metrics coming across. If I do the total count here, this host right here, the total number of replicas of the host components on this one has roughly done 255,000 requests. And then like this one over here is close, about the same, 243. But if I look at the overall, what I've processed so far is 763. So I'm just going to go back here and to see where we're at. And it's still just handing on over to 38. I'm just going to go ahead and just kill this load process here. And actually, it looks like I've already saw it go down to 35 just by automatically doing that. Just wait a moment here. Yep. And so since I already started taking the load off, it's going to start degrading the number of replicas down. And once again, I have every 5 seconds to report the metrics, and then every 10 seconds for it to actually update the workload deployment. So this is really just showing true workload horizontal autoscaling, not pod autoscaling. And once again, you would normally put this against your ingress for back pressure and not really in this type of case. So I will pause if anybody has any questions on this. Okay, so I don't think I see anybody's hands. Oh, yeah, all right, awesome. Okay, so going on to the next thing for Helm enhancements. This is something that Bailey and I and the rest of the team were talking about. And this also came up from Mike on our WasmCloud Slack channel yesterday. He ran into an issue with using Sad, Sadia, Sadia, saying it wrong. Bailey, help. Live, no, live. All right. Anyways, I think it's
Canadia?
Synadia. Thank you, Synadia. There you go. Yes. He's using Synadia Nats, which is a distributed Nats cluster. And he was asking, how can I set Nats inside Wasm Cloud to point to Synadia versus the installed Nats instance? And yes, you can do that, but it's actually kind of hard. It doesn't make sense to do so. I mean, you can use customize, but the way you use customize is you set up an external service inside Kubernetes, and that would basically route to the thing of the same name as this. So you're kind of not changing the hard-coded name that our Helm chart's looking at. So this really triggered off, okay, what else do we want to make configurable inside the Helm chart? And it's really everything. Anything that's hard-coded really should be a default value. And that's our opinionated install. But if you do have a cluster that you're deploying into, especially if you're self-hosting your Nats install, maybe you have a Nats team that's only focused on the health of Nats, then yes, you should be able to use that. The other thing we came up with is there are times that you actually might want to have a control plane slash scheduler Nats URL or Nats instance, which is just for communicating between the host and the runtime operators, as well as have a separate Nats installation for just your workload components to talk on. So that way you don't have any type of crosstalk on subjects and things like that might happen. So that's why we're adding even another Nats configuration as well. And then there's also having the ability to bring in your own in environment variables, as well as pass in additional arguments into the actual containers that are being deployed. Now, the argument side makes a lot of sense for if you bring your own custom host, because there might be times where you have the default host out of the box, but you do want to add a more not using the host plugin component plugin that's coming up as a feature, but maybe you want to just go ahead and compile it all together. You might have some additional arguments you also want to pass as well. So this is going to be coming up shortly in one of the next releases. Any questions for everybody on the call? I need to do better looking at the.
No, you're doing great. Our next scheduled release, for folks wondering, is Tuesday.
Yes, thank you. All right, so those were the two things I wanted to cover at first. I'm just going to hand it over to Bailey.
Yeah. Okay. So you just actually showed the data nats URL field that we pass into Kubernetes. And one of the changes that I did is reflecting that essentially into into what we run when we run wash dev, when we run a wash dev host. So a couple of different changes, but basically two larger PRs that have landed on main now. So I'm going to demo those straight off of main. Let's look at the configuration first. So I'm building one component, and this is basically my HTTP handler. So the main endpoint, when I hit my local host, this is the first component that will hit. But I'm also running a multi-component workload.
I already have two built-ins. Wait. Sorry.
Hey.
My bad. Sorry.
It's good to see you. Okay, so if we're running with other components that are inside our workload, this component here, this top level component, is going to route to these others, to both task lead and task reverse. Now, this is a template that we had already provided, but it didn't allow you to do multiple subscriptions, and there's a couple reasons why. Reason number one is that we didn't have any configuration affordance for you to be able to do that. And what I mean by that is we didn't have a way for us on a per component level to be able to say, I have my own configuration and I wanted to say subscriptions. I'm going to subscribe to task.lead topic, and this one's going to subscribe to task.reverse topic. So if we look at sort of the architecture, we're going to have a client, we're going to hit our HTTP API, and then this is actually going to post to our message broker. And then off of those subscriptions, either depending on the subscription topic, either it'll go to task delete or it'll go to task reverse. So I'm just going to run that over here. Let's go up a couple. And we'll say wash dev. Open it up. And then here's our little task API. One thing I added to this template is that I also expanded out the UI that we bundle in. Mainly because I actually showed my partner this demo, and she was like, "This is pretty lame. Are you?" And I was like, "Actually, the cool part is this. This is the cool part." But yeah, okay, I'll run the demo. This is we're first gonna do leet speak, so you know. Right. I type something like this and I get this type of leet speak back. And if I change it to reverse and send task, I didn't come up with a unique other task other than just reversing the words. So this demo now has a second component in it and it reverses the words. It also has this little prefix. I don't know if you noticed that when I switched to leet speak, it pretends to be a robot. I switch to reverse. It shows me that I'm actually doing a little reverse. That actually is coming from inside the component. So anyways, now we've got this little architecture view. I hope we can use this pattern for our continuing forward on our examples and templates where, you know, if it's not the coolest of demos, at least like have the architecture on the UI page so people understand what you're trying to like highlight to them and why we think that's interesting. So essentially, we now support being able to pass in local environment variables, local config, on a per component basis inside our dev configuration, so for your local dev. But another key point of like what this what we had to change to make all of this work is if you go into Target, WASI 32, WASI P2, I think it was release. Yeah, okay, here's my WASM. And if I do WASM tools, let's look at the reverse width. You'll see that it's a consumer. So it's pulling in consumer types, but most importantly, it's a handler. So it's exporting, being able to handle these messages. And if we look at our HTTP API for how it does that, basically it's just posting based on whatever that task was. It's going to post and say, you know, go to that subject that I'm configured to go for. So it actually isn't directly linked per se to those components. It's just they're all picking it up off of the message broker. And so if I go to task delete, for example, and here you'll see that it's subscribed and then it does this little leet speak here. But the main point here is that this is its one export. But here's the trick. This is its one export, but also look at this one. Oh no, it has the exact same export. And that was the challenge that we ran into. And basically, we previously were trying to prevent cycles. And so whenever we ran, and actually I'll just pull up that PR to talk through that. Whenever we ran, and me doing a bad job saying things while doing two things at once. Whenever we were instantiating a workload, we were looking for cycles where it was like, oh, we've got duplicate exports, so that's going to be ambiguous for us to be able to do inter-component linking. But it's actually not ambiguous if other components inside the workload aren't trying to import that export. So you don't have a cycle there. And so a lot that landed as part of this change right here. So basically now we say, all right, when we're linking up our components, we still have the check for on the import. So let's say I have components A, B, and C, and component A says, I want to import messaging handler, like that export that I showed earlier. But then both B and C both export messaging handler. That would be an ambiguous import and will fail at runtime. And so the solution for somebody when they run into that would be to either compose their components together by being careful about which instance you actually want to link to and do that with WAC. Or put it in a different component workload entirely. Decouple those from the workload deployment. And it's not a problem if each one of these components all have the same export because the host knows which component instance it wants to call when it's doing that routing. And another aspect of the change here is that we made it so that the in-memory messaging plugin knows how to do that sort of subject routing. So I did that with in-memory. And one other thing is that if I had, not that one, if I had specified a data nats URL, like what Jeremy just demoed for the Kubernetes side, then it would have actually automatically loaded the nats plugin. And in that scenario, I would have also needed to run nats locally. So we default still to the in-memory version for local development, make it easier. People don't have to like bring their own infrastructure to get things working. But if they wanted, they can also use our nats plugin to do this as well. So I think that is sort of the roundup of some of those big changes that landed. Questions? Oh yeah, and I did it for TypeScript too. So if we go over to the TypeScript repo, you'll see the basically the exact same template name and with the exact same HTML essentially in it. And when you run it, you can't even tell that you're running TypeScript components versus Rust components. And we could probably, if we really wanted to, we probably could even do an interchange where one task worker is Rust and the other one's TypeScript and vice versa. But right now, we just have all the Rust or all the TypeScript versions, and I'll post that PR in the chat. Here, boom, cool. I think that's it for me, unless folks have questions.
All right, awesome. So now we have our documentation side. Eric, do you want me to go over that, or do you want to present, or?
Maybe if you've got the agenda, maybe go ahead.
Absolutely. Okay, so there's two things we wanted to go, just to present to everybody. First off is our 2.30 release that literally came out last week. And it just adds several new enhancements to wasmCloud. It does have some additional fixes to WASI OTel support, as well as how to do workload environment config and secrets inside the wash config YAML for wash dev. So please, check this out inside our blog. One other thing to call out, it does have a loud host now in there too, especially inside the examples. So this is a good way to show from even an egress side from a workload component that you're able to control, what data is passed to where. The other thing we wanted to call out is we have some updated documentation on our ingress. And this is really useful. So once again, just looking at our wasmCloud Slack, with the change from going from runtime gateway that's now deprecated to being more Kubernetes-native as far as using services and endpoints. This really just goes into an overall architecture on how you can configure it first into an ingress, which then goes to service. Kube proxy looks at the service as well as the endpoint slices that are registered, like I showed inside the demo. And then that's how it's going to know which IP address to pass to the host pod, which the host will then inspect what the header is coming in and as well as the request coming in to figure out which WebAssembly component the whole thing gets routed to. So this section right here underneath the operator manual is very useful for just explaining how everything now all works the 2.30 way after runtime gateway. The last thing to call out, and it's very, very important, WASI P3 vote is tomorrow. Bailey, I'm not sure if you want to add anything more to this or not.
Guess what, folks? We're almost there. It's very exciting. It's very nerve-wracking. Eric has a really great PR up on wasi.dev that's in review. That's kind of doing the refresh, framing everything around WASI P3, calling out the WASI test suite. Victor has successfully gotten, along with Tomasz, working WASI test suite compliance for Jaco. So you can go and pull off a main off of the WASI test suite, which is in the WebAssembly repo, and run that, and you can see that Jaco is compliant. And that makes it the second reference implementation. Wasmtime was already compliant. And so with 2 reference implementations, and so long as we have a full consensus tomorrow, we will be launching. What does that mean for us? For us, we're going to enable WASI P3 by default pretty soon after that. Alex is going to go and enable the component model async feature flags enabled by default over in Wasmtime. It won't be, it won't, I don't think it'll be in Wasmtime 46. The latest release is Wasmtime 45. 46 has already branched off and is undergoing fuzzing, continuous fuzzing. But Wasmtime 47, I believe, will be the one that'll have all of this enabled by default. Aiming to also bundle in the WIT interfaces from 030. So once we vote, we say we want it, I will create a release that creates OCI artifacts with WASI 030 inside it. So there's going to be, some automation glue spreading out after we launch, but that is the go-ahead for everybody to begin integrating and embedding and enabling it by default. So, yay.
Exciting times.
Any questions on that? Oh yeah, Aditi, I've been playing with your PR. It's great. Nice work, man. You're working on being able to share values basically inside the same store. You and I are talking about what it would look like with multiple stores. I've got thoughts there. We need to talk through that at some point, but maybe not today. It's a little confusing, but maybe if you get a chance to read some of the docs that I sent you, and then we can dive into it together next time. Cool.
Okay,
Yeah.
I think that is everything on the agenda. So opening up to the floor, if anybody has any other things to discuss. All right, and if not, then happy Wasm Wednesday, and we will catch you all next week. All right, thanks everybody, and if there's anything else prior to that, hit up our WasmCloud Slack group.
Thanks, folks. Bye.